Okay, good morning everyone. So myself Devobroto Kumar Das from Dumka Engineering College. Today we will take the subject is control system. Am I audible?
Good morning, sir.
Yes, good morning.
Yes, sir.
So just wait, I am starting. Okay, so let's start. So we have discussed in last classes. This is the important topic in our stability analysis in control system. This is the root locus method. And in this root locus method, we have explained certain examples, one or two, something like that. What is the root locus and what is the basic properties of this root locus method? And also we have to explain the application of different characteristic equation of a control system. Okay, so in this regarding root locus method, there are lots of process. Okay, how it is solved in different characteristic situations. Okay, so we have to explain today also one by one. So first of all, we have take the one examples, then the clear idea in the previous classes also. The examples is, so my whiteboard is visible, everyone.
Yes, sir.
So this is the example. Sorry, topic is root locus. So you have to given the equations. Uh, Given characteristic equations. This is the GS. This is equals to K by S into S plus 2. And here the feedback value is HS. We know that that is equals to 1. So when feedback is it is 1, that means the system it is also unity feedback system. Okay. So question is obtain the root locus. So this kind of problem we have discussed in our previous classes also. So first of all, you have to see the what is the characteristic equation is given in the question format. This is GS equals to K by S into S plus 2. So in this case here you can see this is the basically highest order in the second order system. That is the S multiplied by S plus 2. That means that S to the power highest power here is to the power 2. So that means the system is second order system. Okay. And here HS, that means the feedback. This feedback it is also that is the value is 1. That means that it is called a unity feedback system. Okay. So now how it is solved? So first the given characteristics equation characteristics equations. This is also we know that 1 plus GS into HS, this is equals to the 0. Now you have to know the value of GS and also value of HS. So we have to put the value of GS and also HS. So what is the value of GS? GS is the equation given equation in the questions. That is also K by S into S plus 2. And what is the value of HS? This is the unity feedback system. That is the value is 1. So 1 into multiplied this one, these are the same. Okay. This is equals to, that is the 0. Now you have to solve this equation. I think the equation is coming in that part. This is the s square plus, that is the 2s, sorry, this is the s, that is the s plus k, and this part it is multiplied by 0. This is equals to, that is also 0. So this is the basically a required characteristic equation we have to solve from here. So in this case here you can see this is the highest power is the 2, that means it is called the second order system. Now you have to calculate the root of the characteristics equation in the given problem. So the two root, why two roots? Because here you can see this is the highest power of 2, that means the second order system. So that's why the root is also 2 roots of above equations are. So this is the basically we have to not factorize from the middle term factor. So when this is not solved using the middle term factor, you have to put the equation that is we also know, that is equals to minus b plus minus the power of b square minus 4ac by 2a. Okay, so you can easily apply these rules into this equation. So I think the equation is coming. That is first one is 1, and also another root is s2. Here the second order system. So that's why the root is number of 2. So we have to represent these two roots. That is one is s1, another one is s2. So equation, we have to put this value into this equation. The equation is coming something like that. 2 minus k, and the denominator but 2 into 1, that means the 2. So this is the basically required roots. One is the s1, one is the minus 2 plus root over 2 minus k, another one is s2, that is equal to minus 2 of minus root over 2 minus k. So we have step by step follow this root locus method. Now we have to put, now we have to prepare the tables, that is the root locus tables, okay, for the various value of the k. So now for various values of k, the roots are, because we know the previous classes, the k value is varied from the plus infinite to negative, that is a minus infinite to the plus infinite side. So in this case, you have to change one by one value of k. The root is also, value is also changes. In either it is positive region and another one it is also negative region. Limited is minus infinite to positive infinite. So you have to put the value of various values of k in the roots, that is s1 and s2. You have to calculate it from here. So we have to prepare the root locus table. This is the k first, that is s1, then also s2. So first we have to put in this equation, that is k equals to 0. You have to put the value of k equals to 0. So when this is 0, it is present. That means root over of 2 minus 0, that is minus 2. One is plus s1 and another one is s2, that is minus. So I think first one, this is s1, it is also 0. Another one, when k is 0, that means also minus 4, it is also coming. Okay. So, right now, 1 minute. This is minus plus minus 2 root over of 2 minus k. So that means when it is 0, that means 2 minus 0, that means the root over 2, that means 1.7, 1.414, something like that. This is value is coming plus, and this is the minus 1. So I think the value is minus something, that is 416.4, something like that. Okay, that is the minus 0.586, I think. Then also you have to put the value that is also minus of the region. Okay, so that means the k is 0, that is also minus of that is one, that is 2 minus of this one, that means the minus of 3.414 minus 3.414. So you can easily put the value that is 2. Okay, then also you have to put the value 4 and so on, and then that is the infinite ranges. So you have to easily calculated the value from the these roots, that is s1 and s2, it is also different value. Okay, so in this case here you can see the number of poles. We know that here number of poles, number of open loop pole, this is equals to, we know that 2, because these are the s1 and s2, and number of open loop 0, this is also equals to here 0, because here equation you can see this is the only k is present here, no one is 0 is present in this equation, so that's why this number of open loop 0, it is also here 0, and the number of roots locus, this is root, only root root locus branches, this is the same thing, branches we have to represent, that is equals to n equals to 2. So number of poles when it is 2, so that means the branches it is also dependent on the number of poles. Okay, so please everyone solve these equations, and you have to determine the different value s1 and s2, then you have to put the value in the graphical method. So this is the basically process we have to learn in the previous classes also. Okay. Now we take the another example, that is the higher order system, that means the third order systems also. So example 2 you have to given, let the equations is, let the equations is gs, this is equals to k by s into s plus 1 and also s plus 3. You have to given only these equations. Okay, and question is obtain the root locus. Okay, so you have to given this type of questions. So let the equation is gs, that is equals to k by s into s plus 1 and s plus 3. But here you can see hs is not present. So when hs is not present, we have to let the value hs is, that is the unity feedback system. That means the value of hs is 1. Okay, so this type of question is given your exams also. So easily you have to calculate the root locus method. So what is the process of this problem solve? So first you have to solve the characteristic equation of the system. So everyone solve carefully in your rooms also. Everyone please solve. So the characteristics equation of the system is, we know that equation, that is 1 plus gs hs, this is equals to 0. Now you have to put the value of GS and HS also. So the equation is coming, that is 1 plus, what is the value of GS? This one, that is K by S into S plus 1 into S plus 3. And what is the value of HS? Here HS is not present. So we have to always, when HS is not present in the given question, so you have to easily put HS is value is 1. That is the unity feedback. So when it is multiplied by 1, that is these are coming the same. So this is equals to also 0. Now you have to solve this equation. Here you can see, you can easily follow that S into S plus 1, then also S plus 3. That means the highest order is coming, that is the S to the power 3. So you have to easily calculate it. You have to multiply the 1 by 1. The equation is coming. I think that is the S cube plus 4S squared plus 3S. Then this is K. That is K. This is equals to this part. That is these are the denominator part. This is equals to multiplied by 0. That is also 0 is coming. Up to this part, it is clear, all of you? Is it clear?
Yes, sir.
Everyone, please respond. Otherwise, I am not understand. You have either understand or not. So this is the basically required characteristic equation we have to solve from the given question. So here you can see the what is the highest order, that is the S to the power 3. That means this is the basically third order system. That means here the root is also number of root is 3. Okay. So now you have to put the value, you have to calculate the value, that is a various value of the from here also. So for various values of k, the three roots of the characteristics equation are given below. Okay, so here you can see highest order of the S, that is the cube. That means the three roots is coming. So the that is first one, it is k, then S1, then S2, another one is S3. So you have to easily prepare this table also. First, you have to put the value is k equals to 0. So you can easily solve this equation in the zero factor. Okay. So please everyone solve this equation of the zero factor. All of you know this process zero factor, because you have to put the value s equals to 0, -1, +1, either or. Okay. 2 or -2, 3 or -3. So then each and every value is you have to put it here. What is the particular factor? It is 0 is coming. So this is the basically required quantity equation we have to solve the third order system. Okay, so the value is I am put the value from my head. This is also when k is 0, that is s1 also 0, s2 is -1, s2 is -3 is coming. Okay, then it is the basically one exact value. When you have to solve the any problem, you have to solve if value is coming, that is the right half plane and also left half plane. We have to put at the particular value when the three roots are same sign. So in this value, when you have to put this value k equals to 0.631, the value of three roots, that is the s1, s2, and s3, it is the same sign, that is a minus 4 point, sorry, minus 0.45. It is also same to same minus 0.45. Another one, it is also minus 3.1. So one point you have to also you have calculated where the three roots of the value it is also present in the same sign, something like that. Then also you have to put the value is k k equal to 5. At this value it is also coming 0.27 plus j into 0.98. Another one that is S2 is coming also j 0.27 minus j 0.98 and also minus 3.5. So another value we have to put it, that is k equals to 12. So this is also value is coming j 1 point say plus j 1.732. This is also negative sign is coming j into 1.732, then also minus 4.1. Okay, so this process is continuing. So the last point we have to put at the 40, that is k equals to 40. So we have to know the ranges of the k is, that is minus infinite to the plus infinite. So in this range, we have to put the value one by one, and we have to calculate the uh, different root, that is S1, S2, S3. But this calculation it is not stable, because you have to put different value, and you have to also calculate the S1 and S2 and S3 different region. So we have to follow the standardized one tables. So in that case, you have to first zero you have to put it, then the any particular value is put it in the a, there are same sign are coming, okay, in this 1 and 2 and 3 and etc. So when this is 0.631, we have to put at the value of k, the required equation which is the same sign, different value you have to put it here. And also again you have to when 12, that is a one is positive, another one is negative, and also another one is negative. So after prepare this table, you have to put it this value into the graphical representation. So we have to go the next page. So now the roots determined above in the graph paper in S plane is shown below. So I am drawing one picture, so a little bit idea is also clear. This is the real axis. This is the one imaginary axis. This is a real, and this is the imaginary part. So in this case, we have to put the different value. First, this is the center point, and the value is here also equals to 0. Then also, this is the basically uh, required, that is the -1. When the -1, that means the when the value of put it in the equals to 0 into the uh, root S2 it is coming, that is also -1. And this process is continuing. You have to calculate it, the value is also another one. It is also when k is equals to 0, the S3 value you have to calculate it from the table, that is S3. Okay, so this process is continuing process. This symbol here you can see little bit something like that. So this is the symbol of the breaking symbol. So that means here we have to put the value of K is the infinite range. So you have to put it the value of the K different region. You have to calculate the different roots, that is S1 is to S3 and so on. And this point, it is a basically center, one point we have to calculate it where the same roots are same sign. That means 0.631 in this point. So this 0.631, so we have to get this value. So I just little bit, it is also drawing here one circle, it is coming. So not this time. Something like that. This one also, this one also. Okay. So this is the basically point of the where K is equal to, that is 0.631. When K is 0.631, every roots, that is S1, S2, and S3 is the same region. Okay. So this is the basically required process. And this is the J1. This is also the minus of J1. One is positive region, this is the negative region. Okay. You have to put the value, that is K equal to 12. Another one, it is also this is the minus of K equals to the 12. So little bit it is also picturization is coming in the graphical paper. So what is the number of poles in this equation, characteristic equation? That is the number of open loop poles, that is P equals to 3. Why it is 3? Because we have to follow the highest order of the S, that is also the S to the power 3. So that's why this is the basically pole P equals to, that is the 3. And what is the 0? 0, that is also the Z equals to, that is the 0. Because here you can see what is the equation. This is K. K is, that is only K. So that means 0 part is not here. So K is that. That's why Z equals to 0. And here 3, that is the highest order is third is coming. So that means the 3 is pole. One is S. Another one is the equals to 0, is equals to -1, and is equals to -3. Okay. Next, number of root locus. Number of root locus branches. We have to represent that it n equals to number 3. Okay. Because number of pole and number of branches, it is also same to same. So it is clear, all of you. This problem, it is clear, all of you. So please respond me, is it clear or not? "34 members are present, but anyone is response not given. Is it clear?"
Yes, sir.
So please everyone response me. आप लोग क्लास में चुपचाप बैठ बैठ रहे हो, बट कोई रिस्पॉन्स नहीं दे रहे हो, तो यही कैसे चलेगा? ऐसे चलेगा तो हम क्लास बंद कर देंगे, आप लोगों को अच्छा नहीं लग रहा है, ऐसे हम सोच लेंगे, एचओडी सर को रिपोर्ट कर देंगे। जैसे सभी लोग अटेंडेंस के लिए आते हैं, कोई रिस्पॉन्स नहीं देते हैं क्लास में। Okay, so we have to solve in different example in the previous classes and also today classes. So in this regarding, we have to coming in the one features of the root locus method. Now, this is one important point: the features of root locus. One question it is also coming in your semester. It is very, very important. Okay, root locus method. So what is the features? So we have to explain one by one. So we have to explain what is the value of k is ranges is we know that is minus infinite to the plus infinite. So first we have written the root locus. The root locus starts, that is k equals to 0, from the open loop poles and terminates that is equals to the k equals to infinite on either finite open loop zeros or infinity. Okay. Number two, you have to follow the number of separate branches. Branches of the root locus equals either the number of open loop poles, that is P, or number of open loop zero, whichever is greater, whichever is greater. So please remember these things also. The number of branches, that is n, this is also same, either it is also root locus equals either number of open loop poles, that is the p, and either or the open loop zero, whichever it is the greater than. So when pole is greater than the zero, so that means the number of branches it is equal to the poles also. Number third, you have to imagine the root locus is symmetrical with respect to the real axis. Real axis. Okay. So we have to put the value in the real axis also, where the different value of k we have to changes. When k is changes, the different value of root is also changes. Okay. Next, at some point on the root locus between two open loop poles, the root locus breaks away. Breaks This is another one point. We are coming this point also in the next classes also. This is the break away point or break away point. Okay. So this is the basically one sum point on the root locus method. It is between the two open loop poles in the root locus method. It is a break even point. Okay. Number 5, we have to imagine for a higher value of k, the root locus can be approximate by asymptotic line and this line intersect at a point on the real axis. Okay. Number 6, the root locus intersect the imaginary axis. Imaginary axis. Then the point of intersection are conjugate. So these are the basic rules, that is the features we have to explain one by one. So you have to remember these features of the root locus method. So in this point, the root locus, it is intersect the imaginary axis, that is the y-axis. Then the points of the intersect the conjugate point. So when we have to calculate the break away point or break even point in the next classes also. So we have to clear this idea is a break away point where we have to apply the in this imaginary axis where the point of the intersection which is conjugate is an other also. Last one, everyone write your own name and roll number in the chat box also. And Gautam, are you present?
Yes, sir.
You take a screenshot, okay? So next, from the open loop complex, pole, the root locus departs. So after this class, all of you please join after 2 minutes, okay? So departs, making an angle with the horizontal line. Horizontal line. So from the open loop